I've put together a list of tools, supplies, and components to get you started on your digital electronics hobby. This is starting with the basics to if you wanted to get a microcontroller going or some simple digital electronic circuits. I've added several links in the description where you can buy some of these things, so be sure to check that out at the end. First up, we have the kind of foundation here. This is a breadboard. Components you can see plug into it. Through-hole components, if they're breadboard compatible, will just plug straight into and you can snap them in. They come in all shapes and sizes. The size doesn't really matter, but you're looking for something kind of like this. You need at least one of these. 2 or 3 is better because then you can have multiple projects set up at once, or you can combine them into a larger project if you have something more complex that you're working on. Also, it's important that you don't go with the cheapest breadboard you can find. Spend that extra $2 or $3 per board to get one that has a better chance of having a good connection with all of your components. To connect things on the breadboard, you will need some jumper wires. I have some of them here. This is just a small sample. I've actually bought a whole bunch of these, a sorted kit right here. You can wire them up like this. They just stick into the holes of the breadboard right here, and they're really easy to connect and wire them up. I recommend getting multiple colors so you can kind of distinguish between the two. The orange ones and the blue ones here are carrying different data signals, so I can kind of trace where those data signals are going on the breadboard. The next thing you're gonna want is an LED pack. I have one here. It has tons of LEDs in here. You can see here I have different sizes, different colors. Some of these are clear before they're actually turned on. Some of them are actually colored in the plastic of the LED itself. LEDs are a staple of digital electronics. They can show you really easily what's going on. They look pretty. Things you can build like cubes out of the LEDs that have light patterns flashing all over them. The thing that you're gonna need in addition to the LEDs are resistors. I also recommend a multi-pack for this. They keep voltages at the right levels for your circuit. They do other things like you may have heard of pull-up resistors and pull-down resistors. So you're gonna want a lot of these to do various things with. So a multi-pack is great. The last thing you're gonna want for this kind of setup as far as components go is a microcontroller. There's a wide variety to choose from. You may have heard of Arduinos, Pi Nanos, Pi Picos. There's all sorts of stuff out there. What I would recommend for beginners is to look at Adafruit. They have these things called feathers. They have several dozen of them with different microcontrollers on there. If you go to adafruit.com, you can search for feathers. A really simple one is a Raspberry Pi Pico based one. It's a really cheap kind of microcontroller that you can get that you can control LEDs with and is expandable later with the entire Feather ecosystem. The Adafruit Feather ecosystem is actually wonderful. All sorts of things like these LEDs with these 14 segment LED displays, that's part of the Feather ecosystem. So I highly recommend getting into that as a beginning point. This is a soldering station, which you definitely want a soldering station, not just an iron. They also have a temperature control on them. So you want to be able to adjust the temperature. Oh, interesting. It's going to be much easier to solder if you can get it right where the solder is really melting well for you, and you need a temperature control to be able to do that. The solder stations usually come with a sponge that you can put water on to help clean your soldering iron, and some of them come with, they're like copper shavings, but they're like in little curls, but you can also use that. Prolong tip life by removing oxidation. I started with this soldering iron. Recently, I have upgraded to this one. I haven't even turned this one on yet. I came to the point where I was soldering surface mount stuff, like really tiny little integrated circuits that I need this, I don't even know what it's called. Air gun? Yeah, sure, we'll call it an air gun. Why don't I know what that's called? Anyway, it blows hot air at a temperature controlled hot air out the tip of this, and you can heat up a section of the board and melt the solder, and that's what you need in order to do some of the really tiny surface mount stuff. Just keep in mind that if you get really into this, you may be upgrading to one of these or buying a separate air gun later. You also need some solder. I recommend getting something thin. Let's see, what is this? This is 0.8 millimeter. If your solder is really thick, it's hard to get it in some of the small spaces. I also recommend going lead free. It's not worth poisoning yourself with lead. There's also solder wick, which comes in these little plastic things. And this is basically a little strip of mesh copper mesh that soaks up solder. So if you make a mistake, you can use some wick to kind of wick away the solder. Then there's also flux, and you can just start with a flux pen. Basically, you want a no clean flux. And all flux does is help the solder flow onto the components. It helps you get a good clean solder connection. The other thing that you're gonna want is a digital multimeter. The real thing that you want with this is the continuity checker. After you solder a bunch of joints, it's really handy to be able to make sure that you have continuity between different points on your PCB, or that your signal is making it to its destination. And so that's, these are little tiny little tweezer things. With soldering, you need some really fine motor control. So these are super helpful. So that's soldering. No, one more thing. You see this blue mat here? The thing that you really want from this is the heat. You want to solder on this so when solder drops, it hits the pad, not some table or something else. That's basically what you need to solder. Another nice to have, I ran into this recently, is you really having a good pair of small wire cutters. For example, this was a LED feather from Adafruit. The little pins that come through the soldering board are really, really close to the other components here, and that's what these are for. So you can get in there and you can clip these little wires so that you get them out of the way. They don't cause short circuit. They don't get in the way of putting in a breadboard. Anytime you're soldering on a PCB or anything like that, these are handy to have around. But the one thing that I really would suggest you don't skip on is the oscilloscope. If you are sending communications across a breadboard, designing PCBs with communications, you're gonna need an oscilloscope to see what's going on. Because sometimes you're like, this isn't working, but I have no way of diagnosing what's going on. But if you can see the signal that's being sent, what the voltages are and how they are changing, then you can a lot of times figure out what's happening. So this is invaluable. I am building processors and I'm aiming for roughly 50 megahertz on those processors. The bandwidth needs to be, I think it's 5 times that is what's recommended. 5 times 50 megahertz is 250 megahertz. That's a lot of bandwidth on an oscilloscope. I don't have 250, I only have 100. Realistically speaking, when I'm really going at my full 50 megahertz processor, some of the signals I'm trying to diagnose may be just beyond the limit of this oscilloscope. So this one is 100 megahertz and it does a gigasample per second for 2 channels. If you do a 4, then it only does 500 megasamples per second. The megasamples per second are a measure of how much data it captures and stores in memory. If you have the budget, I would recommend 50 to 100 megahertz bandwidth with a gigasample per second on at least 1 channel or better. If you're gonna stay typical microcontroller stuff, that's not a problem. If you can do neither of those levels, I would actually recommend going with a super cheap one. Get a portable oscilloscope. Your goal with buying a portable oscilloscope is to prove to yourself that this is something you want to do. You can save up and get the full oscilloscope later once you have the budget for it. These are really nice to have, not necessary. But I cannot stress this enough. You're going to be really disappointed in digital electronics unless you have some form of oscilloscope to figure out what's going on. A full list of this, everything I've covered, will be in the description, plus links to potential places where you can buy them. I'm not going to recommend you buy it from a particular place. I bought some of this on Amazon, some of this from some other places. If this was helpful, I would really love it if you would give me a like, and definitely leave a comment if you have your favorite piece of thing that you can't do without. I'm doing a whole playlist on a lot of beginner electronic stuff. I teach you how to solder, I'm teaching you how to work with microcontrollers. Check this playlist out. That will expand over time with more and more very helpful, I hope, beginner tutorials. See you next time.